Hey, welcome everyone into the NGK Tech Garage. Thank you for joining me today. Today we're going to be working on a misfire problem on this awesome 2014 Lincoln MKZ that's sitting behind me. This does have the 3.7 liter in it, but really the testing and the procedure and the diagnostics that we're going to perform today are really going to apply to just about any vehicle that you're dealing with a misfire on. Just so happens we're looking at a Lincoln, but you can apply this to just about everything. It's not only particular to this vehicle. Now, before we actually get into doing the diag, I want to go over two quick things. One, if you guys are looking to get announcement emails or notifications about these live broadcasts happening, head out to ngktechportal.com, just like that. It'll bring you up to our new tech portal. If you go ahead and create an account, you'll have to put in your email address and a little bit of other information, and that will get you added into our mailing list, okay? So I take the names and emails right out of that account and add it into our mailing list that goes out usually about a week before we go live, and then the day that we actually go live. So if you're looking for those announcements, if you want to get notified that this is happening, please go ahead and sign up there. Also, when you sign up there, you'll have access to the training that is available there as well. So the other thing, I said we have two things. The other thing, t-shirts. This guy right here, a lot of you guys have already won these, a lot of the regulars. If you haven't won one yet, you're in luck. We're giving away 5 of them at the end of the broadcast. I'm going to ask a question. You have to email me out the answer with a reasoning why. I want to know what your answer is and then why that's your answer. If you get it correct and you're one of the first 5 to send the email, then you will win one of these awesome Diagnose Before You Triagnose t-shirts. If you just want to send me out an email anyway, even if you've already won a shirt or you just want to give it a shot, you know, I'd be more than happy to give you the right answer then. So, diagnosing a misfire. We see misfires a lot on cars, a lot of coil problems, a lot of whatever, carbon issues, just a lot of problems with misfires on cars today. This one is really no different than any other misfire problem. We're going to diagnose all of our misfire problems kind of the same way. There's a lot of things that we can do very quickly to be able to rule out one of the 4 or maybe 2 of the 4 things that an engine needs to run. So we need fuel, we need air, we need spark, and we need compression, right? We need those 4 things to occur inside of our cylinder in order to get our event. Otherwise, we end up with a misfire. And really a misfire, all that means is that the PCM has noticed the crankshaft slow down during that firing event. It hasn't sped up. So first things first, we're going to check codes, right? And just like the title says, we're dealing with a, should be in here, a cylinder 4 misfire code. Also a misfire detected on startup. So nothing too out of the ordinary there. Luckily for us, cylinder 4 is actually really easy to get to on this engine. So cylinder 4 is on bank 2 of our engine, which on a Ford, and this application just happens to be on the front. So we'll have 4, 5, 6 on the front bank, 1, 2, and 3 on the back bank. So we're going to do some testing that's going to be right at that cylinder, and then we're going to do some testing that we're going to do through the fuse box, which is going to be really handy if you guys are diagnosing vehicles with the misfire under the intake, because there's nothing worse than having to pull the intake, do the old part swap, throw the intake back on, and figure out that the problem hasn't changed. It hasn't moved cylinders. Now you're pulling the intake again and moving something else, okay? We don't want to go down that road. So we're going to be able to prove this out without swapping any parts around. So we have a misfire on cylinder 4. Now I always like to be able to confirm that the problem's actually occurring. That way we know what it is that we're looking for. So I'm going to go into functional test and we're going to go cylinder contribution. And what this is basically real-time misfire monitoring. So once this loads, we will be able to look at, okay, I believe the key is on. Let's go ahead and fire it up maybe. All right, so the vehicle's kind of warming up. There we go. I think we just went into closed loop right there. The RPM changed. right, so cylinder 4 is really the one that I'm keeping an eye on right now. The engine is running a little bit rough. It is, does feel like it's idling a little bit rough. I'm going to bring this up off of idle a little and see if our problem gets better or worse. Ooh. Okay. So definitely worse at idle. All right, we'll go ahead and shut that off. Cylinder 4 is definitely the one that's sticking out. Cylinder 1 looked a little bit funky. Now that could be because maybe I'd have to look at the firing order. Maybe cylinder 1 comes after 4 and it's the crankshaft isn't speeding up properly. Hard to say. But cylinder 4 does look to be our problem. It does look like the computer is setting the proper code for the cylinder. Now, this really is happening while you're driving the vehicle in, you hook up the scan tool. What else can we do to gather information very quickly? Well, Ford has always kind of given us this awesome relative compression test. The Ford scan tool has been doing it for years and years and years. The Snap-on tool we're using today gives us this ability as well. So we can go into the tool and we can go into our relative compression test. And I'm going to actually have Brandon help me out with this thing today. So we'll go relative compression. And what this is doing is it's actually monitoring the current being drawn by the starter, applying the overall timing of the engine to figure out which cylinder is contributing and which one's not. So this is kind of doing a mechanical health check of the engine electronically just with the scan tool. So if you want, you can go ahead and read through all that. That's great. Hit continue. We got to make sure we're being safe. And what we're going to basically do here is put the vehicle in clear flood mode. So we're going to hit continue. You'll see that we got to have key on. We have to make sure the battery's okay, and we got to hold the gas pedal all the way to the floor. That gas pedal all the way to the floor is going to put this thing in clear flood. We'll hit continue, and then we'll go ahead and crank it over. All right, great. And we'll see what our results come back with. Cylinder 3, 1 million, is that 10 million? Holy cow. 10,888,900% change in cylinder 3. Kind of odd. Okay, let's do it again. All right. Okay. Okay, cylinder 4, 43%. Okay, so do we actually have a bum cylinder on our misfiring cylinder? Let's try it one more time. All right, Brandon, go ahead, crank it over, please. And let's see what we've got here. Okay, now we have 44% on cylinder 1 and that whatever 10 million percent on cylinder 3. So our relative compression test unfortunately has been mostly inconclusive on this vehicle. Now for those of you that have the trained ear listening to this engine crank over, it doesn't sound like a mechanical problem. It doesn't sound like we're having a cylinder loss or a cylinder issue mechanically. But our relative compression test is giving us some inconclusive feedback. Now, I don't know if this has been fixed by Snap-on in more recent updates. I think our tool right now is set to 17.4. So if anybody's using a newer version of software, let me know. Let me know if that's been fixed in more recent updates. But for what we have in front of us today, the testing is incredibly inconclusive using relative compression on this vehicle. So when our testing is inconclusive, I want to do it myself. Like I said, my gut isn't saying that it's a mechanical issue because it sounds pretty good cranking over. It sounds pretty good when it's running, but for something that just takes, let's say, 2 minutes to hook up an amp clamp around that battery cable, I think it's worth doing. So we're going to grab the big amp clamp here, hook it into the lab scope, and we're going to do the test ourselves because I'm not trusting the software at this point out of our scan tool. So really, this really doesn't take a lot of time to do if you have your lab scope out, if you have a cart set up or something like that, something where you can do this very, very quickly. So just around our positive battery cable, you got to make sure you're around everything going to the positive terminal, because if you're not, you're going to be missing out on some of the current. I guess technically all you really need to be around is the starter cable. But I don't like chasing harnesses underneath airboxes and stuff to figure out which one's going to the starter. So I just clamp it all and we'll figure it out in the end. And then afterwards, or second, here we're going to put in a trigger. So what this is going to do is we're going to hook into our ignition coil primary, because we can kind of almost do two tests here. Let's put the amp clamp in channel 2. Actually, you know what? We'll leave the amp clamp in channel 1, and I'm going to take and do an ignition coil primary check using this as our sync or our trigger. I'm going to go ahead and do this on a known good cylinder just in case. You could do it that way. Let's do it on the bad cylinder just in case we do have an issue there. So we're going to grab that. We'll do this on the cylinder 4. And what we're going to do before we go hooking up, this is a 2-wire ignition coil on here. We're going to be capturing that primary voltage out of this coil. I'm going to go ahead and put a 10 times attenuator on here just to help protect the scope, because we are going to see some high voltages coming out of this thing. So we put our 10x attenuator on there. Let's get the scope all set up. We're using a 10 times probe. We'll go ahead and up this up our time. We'll up our voltage. I think 500 should be enough. Probe 2, we're using the big amp clamp on 2000 amp mode. And let's grab negative 200 to 500 amps. That should be adequate. We need a alligator clip for our scope lead. So I'm just hooking up the negative side of the scope lead to some sort of battery ground source. It looks like I got a ground leg right over here. And then our ignition coil, I'm just going to hook into the control side. So looking at the 3 that are here in front of me, each one is fed with a purple wire. That purple wire is most likely going to be our power going into the coil itself. So with that power going into each of these, it's going to be a shared value. The other color wire, the unique wire at each coil, is going to be our control on a 2-wire. So I'm going to back probe into there. There we go. And because the key is on, you guys can see that little spike that was in the scope there. We made connection right there with the circuit. So when our circuit is open, our voltage flows through the windings of the coil. As long as the coil is not open, it flows through the windings of our coil, and we can actually pick up voltage on the considered ground side of the coil. Okay, so that's that little bit right there that we just saw in the scope is actually verifying that our windings are not open. Okay, so just keep that in mind. All right, so we got our relative compression test set up. I'm going to just take our time base up a little bit more. We'll go 5 seconds. And then all we're going to do is, again, clear flood mode and put this thing, crank this thing over. So gas pedal to the floor. All right, that looks pretty darn good. I think that might be good enough to take a peek at our trace. So I shut the key off right here. You saw our voltage drop, right? We have connection to our coil. We are not showing an ignition sync on our coil. Maybe a red flag, right? But right now we're chasing after a potential intermittent question. Taking a look at this briefly, it looks pretty good. We're going to grab 6 of them. 1, 2, 3, 4, 5, 6. Grab an extra just so we have the repeat and drag it down. Looks pretty good. Now we don't know what cylinder's what because our sync from our coil isn't in there, our ignition sync. But looking at this, and we can start scrolling through it, I don't see anybody at 40% loss or 10 million % loss like the scan tool was telling us. This is a pretty good looking relative compression test. I would not be concerned about our mechanical health right now. It looks pretty darn good. All right. Now what I am concerned about is where's our trigger for cylinder 1? Why is our coil not being triggered? Now, like we talked about early on about the swapping parts, a lot of people will take a cylinder 4 problem like we're dealing with right here, take that coil, take that plug, swap it over to cylinder 5, right? If the misfire follows that coil, then you know that you got a bad coil and bad spark plug potentially. I usually replace them both in a pair just because it's possible one took out the other. But if the misfire travels with the swapped parts, then you know you've found your issue. The problem with that, the problem with swapping parts around is, one, you're disturbing something. What if you swap the parts around and then you have no misfire? Now what? 2, what if the coil were shorted? Okay? What if that coil here had shorted windings and this guy here took out the driver inside of the PCM? Again, this is a 2-wire ignition coil. The driver is in the PCM. This is not a smart coil. It's not a 4-wire module controlled coil. What if that what if that coil took out the driver in the PCM? Now you're diagnosing a customer's vehicle or your own vehicle that came into the shop. It was running rough, but it came in here under its own power. It did not come in on a flatbed. What if you take that shorted coil, put it in cylinder 5, start this engine up, watch your misfire counters on your scan tool, and all of a sudden, now your misfire's on cylinder 5, and your misfire's on cylinder 4. Now you're in trouble. What if you swap the parts back around and you're still having misfires on cylinder 4 and cylinder 5? You've just damaged this vehicle. This vehicle came into you under its own power, running on 5 cylinders. Now it's potentially only running on 4 cylinders. That's a problem. Let's say the customer declines repair. You diagnose it, you figure out, yes, it needs a spark plug, a coil, and a PCM on this vehicle, or the PCM to be repaired. What if the customer says, no, you know what, I'm not going to fix it. I'm going to, whatever they're going to do, they're going to leave there with an engine that runs worse than when they came in. You've damaged their vehicle. Now is where you get into this shady area of, well, you broke my vehicle more. You know, it came in here running on 5 cylinders, now I'm only running on 4. The vehicle is running worse. What did you do? It's your fault, fix my car. Okay? You want to avoid those nasty conversations with customers because you swapped a part around, okay? This is very possible when dealing with 2-wire ignition coils, okay? So we're not going to swap the part around. We're going to just take our lead here, and I want to see if in clear flood mode we have ignition control on cylinder number 5. So I'm just going to do the same test again. And actually, yeah, we'll just do this real quick once more. And we should, as I turn the key on, see that little voltage spike. And then we should see this thing okay. So we don't have a misfire on 5, but we're still not seeing ignition control. And the reasoning behind that is we're not controlling the ignition coils when this thing's put in clear flood mode. Okay, the PCM is not grounding the coil and creating spark when we're in clear flood mode on this particular vehicle. Now that's not always the case, but it is the case on this one right here. So we still want to verify our ignition primary control. So why don't we go ahead and do that? Since we've already got one hooked up, let's go ahead and let's hook up. We're already in 5, which is our known good. Let's go ahead and hook into 4 to capture our potentially problematic cylinder. And again, we're running a 10-to-1 attenuator on here to make sure that we don't overspike or overload our scope with voltage. I don't remember off the top of my head what the spec is on here. I should, because I think I talked about it in a previous class. If I remember right, it might be 200 volts, but don't quote me on that, please. A lot of times they're 100 volts, but something in my mind is saying 200. If anybody knows in the chat, could you please tell me now what it is? Okay, I'll wait for that to pop up. Anyways, we're going to hook into here. We're going to hook into our coil. And again, we're on the odd colored one. So at coil number 4, it's a green wire. Coil number 5, it's like a whitish color. I haven't even looked at a diagram yet because we're using some deductive reasoning here. If we're sharing wire colors between 3 coils, it's got to be power flowing in, right guys? It's got to be. They're not going to share the same color. We're going to pick out the oddball. That's going to be our control. Thank you, Chris. 200 volts on this guy. We don't want to exceed 200 volts going into our expensive tool. We don't want to break it. That's why we put an attenuator, which all it is a little add-on piece right here for both channels 1 and 2, because we're going to capture primary on there. All right, so let's set this guy up here. We're going to change channel B now to our 10X. We're going to create our voltages the same. And now what we're going to do is we're going to fire this thing up and see what happens. So what we should see is a blue trace and a red trace that are spiking. And when it's zoomed out really far like this, it's kind of hard to tell exactly what it is that we're looking at, but we're capturing data. So I think that's enough. Go ahead, shut it off and pause our scope. Take a look at what we've got. So we got some fluctuations here in overall peak voltage, and it's possible that the peak voltage required is lower for some of these events, or it's possible our scope isn't capturing fast enough. We didn't turn up the capture rate here. Either way, let's take a look at just a couple events when we zoom in. We'll just grab this one right here. Alrighty. And we'll zoom in even further. So again, blue is our cylinder 4, red is our cylinder 5. So let's look at our known good. We have our coil being grounded by the PCM. We have the moment the ground is released and we induce all that pent-up rage onto the secondary windings. And then we come down, we go across the spark plug itself, we burn that mixture inside, and then wait, Ford does their good old secondary spark, or sometimes even triple spark. We're going to ground that coil again and give it another little kick. So without getting deep into an ignition pattern, this is from a known good cylinder. We'll treat this as a known good at cold idle right now. We'll leave our zoom alone and just try to scroll down our scope here. That's a small one. That's kind of a funky looking thing. Let's grab that other, there we go. Again, our coil is grounded. We have our inductive kick right here, punches up to about the same voltage level, comes back down, goes across the spark plug, so it's not a direct short, it's not a direct open, comes back down, grounds again, kicks again with a smaller one. Looks pretty good. But the biggest thing here, and without even looking at the voltage levels or the spark line itself or any of that, without really picking at it so close that it takes a bunch of your time to figure out what it is exactly that you're looking at, we've confirmed 2 things here. We've confirmed, 1, we're feeding power to both of our coils, known good and potential failure, and 2, we're able to ground side control both of them. Our PCM is healthy at this point from a high level overview. Now it's possible that if we rule out everything and we have to make our way back to looking at spark and we have to dig in deeper to this, it's possible that we could have maybe a driver that's not completely grounding, or something that if we really picked at this, we could maybe find something in here. But from a high level, few minutes into our testing overview, we know our PCM can control our coil, and we know our coil is most likely creating sparks somewhere. I guess we don't exactly know that it's happening across the spark plug gap. It looks like it, judging by the pattern, but we don't know that 100% for sure. I'm like 90% certain on ignition right now. So mechanical health looks pretty good. Ignition looks pretty good. Fuel? There's one other thing that we can check. Let's say that we're not dealing with cylinder 4, okay? Let's say we're dealing with something under the intake, harder to get to. We can go ahead and we can put a current clamp on, and we can check all of our ignition coil's current draw. We've done this before in other videos. You can see, here's our fuse box. Now what's weird, about this one. Where's my needle nose pliers? Here we go. I've already looked it up in the diagram. The ignition coils are fed through this 15 amp fuse right here. And now it might not look too funny from where you guys are seeing it, but look at this. Three legs. Kind of weird, right? So currently, at this current moment, I do not have a fuse jumper lead that is meant to test three-legged fuses. I don't know if there's one out there. If there is, please guys let me know in the chat. I'd like to get a new tool. We could rig something up on here with some jumper leads and do a current test on this coil. Up to you guys. What do you guys want to do? Should we check current draw on these coils? If this were your car, you were diagnosing it right now, and you were at this point, would you check for current draw on the coils? Do, 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 do. Alrighty. So I see a no. So I think we're going to skip that test today. We've done ignition coil current draw test before in other videos, so make sure to check those other videos out. We'll skip that for today. So, unless you guys really wanted to see it, but okay. So we now have 3 yeses. So I guess we're not skipping it. That's fine. It's not going to take long. Pull this fuse back out. Now, the way this fuse is designed, if we can go to that, there we go. The leg coming in the middle here is 15 amp fused in each direction. So this leg in the middle is our main, this is really hard for you guys to see. This leg in the middle is our main input going to 2 different outputs, okay? So what we're going to do, we're going to rig something up here with a fuse jumper lead, because I never put a jumper wire in without a fuse because there's just so many potential things that could go wrong. I don't want to be the one that makes it go wrong, especially when we're live on camera. So I'm going to take my fuse jumper lead and I'm going to put it into the center pin on this fuse. And then I'm going to take my other 2 leads and put them in either side of that. Beautiful. And then we're going to take and we're going to hook those other 2 leads into this little doohickey here. And then we're going to take our fuse jumper lead, hook it into this really high-tech alligator clip here. And just like that, we have a 3-leg fuse jumper. Now we're going to take an amp clamp and we're just going to throw it around that. I think I'm just going to put it around that main leg. And yes, we'll get to fuel in just a little bit here. I want to just get done with spark and then we'll jump over to fuel. So we're going to grab channel 3 on the scope. We'll turn that on for a 20 amp clamp. Turn that on to, I don't know, we'll just go to 20 amps. We can always zoom in. We'll zero this guy out. Throw it along our main fuse leg, because I didn't look at a diagram and don't know if it's the right side or the left side that's powering our coils. I'm just going to grab them both through our main feed and make sure that everything is happy under here. We'll get this guy out of the way and let's see what we've got. Somebody's not connected. Oh, I bet this is power and ground on here. Oh, that's fun. Let's try this. Always verify that your test leads work before you go live. So I bet what I was doing there was feeding the wrong side in there. Let's try that again. Because I bet we didn't have any spark there at all. Hey! Okay, cool. So, our amp clamp was upside down and probably didn't capture all of our amperage. Let's flip that around quick. Sorry about that, guys. And get our scope started again, and let's try that again. Come on. One more time. All right, good enough for me. All right, we'll zoom in, just try to grab a couple traces here. All right. So these dual spikes, again, are that amperage draw, that multi-fire, multi-strike ignition system. Looking pretty consistent, coming in at 8 to 9.5 amps or so, 8.5 to 9.5 amps. Jumping all over a little bit, but nothing that looks consistently out of the ordinary, nothing that's consistently higher or lower than anything else. So ignition coil amperage looks pretty good. Okay? So I think we can kind of rule out ignition at this moment. I'm going to go ahead and put this fuse back in before I accidentally short something out because my lead falls off. Looks pretty good on ignition at this point. So injectors. That's going to be next, right? Fuel. Obviously, we don't have a fuel pump problem, otherwise the vehicle wouldn't start. We most likely wouldn't end up with a single cylinder misfire due to a fuel pump problem. We're probably dealing with a injector problem of some kind. If we've ruled out mechanical, we've mostly ruled out mechanical, mostly ruled out ignition. Again, we're trying to do the highest level, fastest test that we can do to diagnose this vehicle. So without nitpicking, I'm like 90% positive both mechanical and ignition are not our problem. Now you could, because there's always going to be somebody out there that wants to be 100% positive before they move on, you could, because we know the coil's being controlled now by the PCM, we know it's not a shorted driver, you could swap your plug and coil, spark plug and coil over to cylinder 5 and really be certain then that it's not a ignition problem. But we're not going to go there because I don't like to swap parts. So let's go after our fuel. I'm going to do the same thing that we have set up here. I'm going to take our primary winding leads from our scope for ignition, and I'm just going to flop them into our injectors. Now, thankfully, our injectors are super easy to get to on here. So each one's being fed with a green wire, so I'm going to assume that's power going in, and then we have a unique wire on the other pin. Both are in there. I'm going to go ahead and pull the attenuators off of the scope because I think we should be underneath that voltage. If you're not sure where your voltage spikes are going to come in for your injectors, probably just leave the attenuators on there. Just going to save any potential issues. All right, so I'm going to turn off channel 3. We'll put these back down to a 1x. Bump that up to 100. 1x. Bump that up to 100. And let's see what we have for fuel injector primary voltage. Or just fuel injector voltage, I guess. Good enough for me. All right, so we see it immediately went up to battery voltage, which is good. That means we supplied power to our injectors. It made its way through the injector windings, and they both are at that same power level. Nice. Let's go ahead and give it the old zoom. All right, so obviously our injectors are firing at different times, just like they're supposed to. I'm going to put a straight line across the top here. Looks pretty consistent. Let's go ahead and let's zoom in on our actual injector control. So this is where the injector is being grounded. I'd like to just throw a quick measurement on this. We'll be rough. Again, this is cold start. We're coming in at, holy cow, we're coming in at 9.6 milliseconds. Kind of a long injector pulse for this thing. But again, it's cold start, and I keep starting and stopping it. Let's see what the other one is. 9.2, so we're consistent, at least with our injector pulse. Now, this would obviously shorten as the vehicle warms up. We go into fuel control, closed loop, that kind of thing. But right off the bat, a very high-level quick check, our injector appears to be being controlled by the PCM. Cool. Okay. So injector primary voltage looks pretty good. What about injector current? Now, I've pulled up a diagram. Somewhere. Here we go. Our injector diagram, or I guess this is all of the everything. And over here are injectors being fed with a apparently blue wire according to this. Click on this, click on this. So now we're going to look for that fuse. Trace that wire back to a splice. Splice 120 goes to fuse 56, 30 amp being fed into there. Now what else comes off of this splice? Follow this guy. Aha. Fuel pump control module. All right. So it's telling me fuse 56 is powering both the fuel pump control module and the injectors. So if we pull fuse 56, we will have no pump control and no injector control, which could be a problem if we want to depressurize the fuel rail, you know, let the engine run, pull the fuel pump fuse type of thing, because as soon as we pull the fuse, we lose injector control. We're not pulsing or opening those injectors. We're not depressurizing the fuel rail, which isn't very fun. So where's my cover for the fuse box? So fuse 56 says it's in the underhood fuse box, but this fuse box right here doesn't go to 56. 55, I think, is its highest number. 55 is its highest number. So thank you to Ford, or whoever's idea this was. This is a dual stacked fuse box, okay? So you might spend a lot of time looking for this. There's fuses underneath. Yay. So we're running tri-legged fuses, and we're running fuses on the bottom side of a fuse box. Thank you for that. This is fuse 56, 30 amp right here. I'm going to go ahead and I'm going to yank this guy out, and I will just put in a quick set of jumper leads on there. So I'm going to just go ahead and throw this in there. So I've got it set up to pin out the fuse, and a 30 amp fuse here in the middle. Throw an amp clamp around this and capture our current being pulled by both our fuel pump and our injector, or injectors. Okay, make sure we're not shorting that out anywhere. Zero this guy out again, hook it on there. Hope that we're going in the right direction. Hope that the vehicle starts. Grab the scope. Turn channel 3 back on. These should pull less. I guess we'll keep it at 20. We can always zoom in. Let's see what we've got. Now I'm going to leave the primary or the voltage in there because, oh, you guys saw this, the fuel pump prime there, right? You saw that current pull for the pump. Okay, let's take a look at that. This guy right here, that's our fuel pump priming. So, kind of a mess. Let's start with just our newest trace here. We'll get nice and tight zoomed in on there. So, kind of a mess, but you can see consistent spikes up here, right? These are our injectors pulsing, riding over the line for the fuel pump. Bring in this guy. We'll call that a consistent top line. Low, 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 low. Do you guys see what I'm seeing here? We got one injector that appears to be lower on its current draw. And when we say lower, we're talking, actually, let's just grab our blue line so we can actually see the difference. We're seeing, let's grab green so it's actually measured in amperage so we don't have to convert anything. We're seeing, doesn't seem like a lot, but 400 milliamps, 0.4 amps difference, roughly, between said injector and the other 5 injectors. Now, what we're going to do is we're going to bring channel A down. Channel A was our bad cylinder voltage. Look at that, guys. Channel A lines up. with our lower current. See that? So our injector is turned on, we draw amperage, but it's not as high as these amperage right here. So if we actually drag in channel 2, you can see again, we line up with an amperage draw, but that one is consistent with the others. So we have an injector, cylinder 4's injector is drawing a lesser amperage than cylinder 5's injector, or the other 5 injectors, really. What leads to a lower amperage draw? Ohm's law, if we're applying both of them with 14 volts, voltage hasn't changed. In order for current to go down, resistance had to go up. So finally, after doing this for a long, well, feels like a really long time now, I finally can find a valid place to do a resistance check. Because resistance just, I don't know, leaves me hanging sometimes. Resistance can just be troublesome. So let's do it though. Let's ohm out our injector. Pull these guys out of here. Now, when you're ohming, ooh, that's a tough clip. When you're ohming an injector out, when you're doing a resistance test on a field injector, I'm looking for something that's not like 0.2 ohms and something that's not like 30 ohms or 50 ohms or 100 ohms or a million ohms, okay? I'm looking for something 10 maybe-ish. And there's usually specs on injectors that you can find. So let's get this on here like so. And again, I'm pinning these out with this kit that I got from AES Wave so we don't wreck those pins. And 61 ohms. Now we haven't looked up a spec. I haven't done that legwork, but I can probably pretty safely assume that is not known good. And just to verify, let's just yank out injector number 5's connector and plug it into there and see what we've got. Ooh, come on, hello. Big difference, guys. There's our problem. High resistance on fuel injector number 4. So current was a big giveaway for us, right? Now, you guys are going to say, well, why didn't you just put the ohm meter on the injector right away? When's the last time, and maybe, I don't know, maybe I just didn't see it a lot in my time in the shop, but when is the last time you put in an injector for a resistance problem? I mean, it's not really that often anymore, right? I mean, maybe back in the day, there were a lot of injector issues, but really, realistically speaking, it's been a long time since I've had to put in an injector for a resistance issue. So it's not one of those first go-to tests. Now, I don't know if this is a pattern failure or something like that on the 3.7 liter. If we look it up in Identifix, if we type in P0304, oops, P0304, not really any sort of pattern failure on here for a Misfire cylinder 4. So I'm going to say that injectors are not a pattern failure on this engine, but we do have a failed injector here. For whatever reason, this vehicle's only got 80-some thousand on it. We got a bad injector. Don't know why, but it is. Could it be fuel related? Most likely not. There could be a little bit to something getting stuck in there, but again, we're looking at the electrical side, the winding side of the injector. For some reason, they have increased their overall resistance than the injectors next to it. So, woo, magic parts appear. We got a new fuel injector that we're going to go ahead and throw in this engine. So I think we'll get our fuse box back to normal here, get our test equipment out of the way, and let's, if you guys want, we'll R&R this injector quick and get this thing running well. But there's one more thing I wanted to show you guys. This is where experience comes in to play. Somebody in the chat earlier, and I intentionally ignored it, but somebody in the chat earlier had mentioned fuel trims. Oh, I forgot to put the panel back on. I'll have to pull that fuse box back up. But somebody earlier in the chat mentioned fuel trims. Okay? So fuel trims are a great little tool to look at when you're dealing with misfires because of the way the car reacts to a cylinder that's down. Now, not every time will you be able to use fuel trims because there are certain failure modes where the vehicle will go into fault mode open loop. Okay? The vehicle will actually function in open loop. Luckily for us on this vehicle right now, it's not going into open loop. We are actually able to obtain closed loop on here because all we're seeing is a misfire code. We're not seeing an injector primary circuit code. We're not seeing an ignition coil primary circuit code. Those types of codes would put us into fault mode open loop. We are fuel system status closed loop right now. And here's the kicker. Right there. Bank 2 reading very, very, very lean. We're dumping 28% more fuel into bank 2 than we should be. Okay? So I didn't want to put this up right away because we have to be able to get to where we're getting. This is something to look at, especially when you have more experience, when you've been doing this for a long time. Fuel trims can sometimes give you an idea what's happening, but do not let them lead you astray because fuel trims can be skewed by the actual misfire that's occurring. So watch what happens when I take and unplug this injector. Actually, better yet, let's unplug a coil. Maybe. Oh, there we go. Okay, open loop fault. Okay, sometimes you will see this occur when you have a bad misfire. It's possible. Okay, so fuel trims aren't always a great thing that you can look at every single time you deal with a misfire. Sometimes they're useful. The reason why we can look at them here is because the computer didn't know that the injector was bad. It's not an open circuit. Like we saw, we had voltage flowing through the windings of those injectors at key on. But the computer wasn't able to determine a bad injector. If it was able to determine a bad injector or a bad coil, it goes into open loop fault strategy. Because the problem with doing 28% positive fuel trim on bank 2, we have one bum cylinder, but we're dumping 28% extra fuel into cylinders 5 and 6. We're over-fueling those two cylinders, and cylinder 4 isn't doing its job. Okay? Keep that in mind. The vehicle doesn't want to do that if it can avoid it. So it'll go into open loop, it'll run off of base fuel tables. Nick, I believe, yes, you could probably shut down an injector on this vehicle, but if we had a spark plug that was failed, if we had a cylinder that was low on compression, if we had any type of misfire on that cylinder that was misfiring currently and we shut the injector off, chances are you're not going to notice a difference. The cylinder already isn't doing its job. Shutting the injector off probably is not going to make a change. Okay? So looking at a singular misfire and shutting that injector off, you probably won't notice it, maybe, but probably not. Individual cylinder trimming is out there. It is present. We are seeing it on vehicles today. I think we talked about it in one of the classes. Honda did it a long time ago using a specially designed exhaust manifold. The air-fuel ratio sensors are sensitive enough today to individually trim cylinders. Eventually here, I believe, and this is just speculation, but I think what we're going to end up with is short-term, long-term fuel trims for individual cylinders. It just makes sense. Why not operate each cylinder individually when they have their own fuel, they have their own spark? They share the intake manifold, sure, but we can control fuel and spark into each of them. Let's control them individually. I think it's just probably eventually going to happen. We'll probably eventually see 4, 6, 8 PIDs on the scan tool for fuel trims. Okay, enough blah, blah, blah. Let's rip this fuel injector out. So this thing is a solid fuel rail. There's no flexi tube across here, so unfortunately we do have to rip off the intake to get this injector rail off the right way. Now, it's going to take a little bit longer, but really this one isn't too bad to do. All right, so we'll start by making sure we have the right size socket. Okay. Ooh, disconnect our hose. Disconnect mass airflow. There's a little red tab under here. These things can be a kind of a bear to get to. All right. And all we're doing right now is pulling the air filter. I'm just going to kind of set it out of the way for now. So there's a kind of a hidden bolt on these right underneath the throttle body. Obviously we have our manifold bolts across the top here, but right underneath the throttle body, a nice long extension, there's an 8mm bolt hiding back there that I'm probably going to drop. Oh. I did drop it anyway. All right, we'll find that later. And we got to just disconnect a couple things up top here. Pull off our purge hose. I don't know if there's a special tool for these clips or what, but they definitely changed them. And then, so you gotta, there's two tabs here, you gotta push outwards and then backwards and they come out. There we go, get that guy out of the way, throttle body. Basically right now we're freeing up everybody that's connected to the intake manifold. We'll unbolt it, get it loose and see what's left. I think we're gonna have brake booster hose, this guy right here. And I think there's one more, like a breather hose on the back side. Can't remember your name of who said it last time. I think maybe it was Pat, maybe, about setting tools on the battery. I haven't set anything on the battery yet today. All right, this is for our brake booster vacuum right here. There we go. Get above our little coolant hose there, and yep, we got one little guy left back here. Looks like a breather hose. Now this would be a good time to maybe do some spark plugs on here as well, because you're going to have the intake off anyway. So might be a little bit of an upsell, plus keeping that customer happy, right? We're going to fix up your car, get it back to running well, and we'll do some plugs right away because the labors kind of overlap. There we go. Intake out of the way. Set that there. Now, like always, guys, first thing I do after intake removal is get this guy covered up because, well, if I'm going to wreck an engine, it's going to probably happen live on camera. So I'm just going to wipe it down for now. We'll clean it off later. And this is just body shop masking tape I've found works best because it doesn't leave any of that sticky duct tape residue. Plus, I found with rags, you cover these things up with rags, and there's little crevices and pockets on the rags that little nuts and bolts get hidden in that you accidentally drop down the manifold, and it turns into a bad day. So tape it shut, that way you know you're all set. All right, so like I said, our rail right here, pretty easy to get to. Problem is right now is it hasn't been depressurized, okay? So Service information says depressurize the fuel rail. So we're going to depressurize the fuel rail. And then we're going to pull off the rail and get to our injector. Safety first, guys. Safety glasses on. All right. Let that sit on that rag. Okay. I set my pick somewhere. There it is. A little hook pick or even a 90-degree pick works kind of nice for disconnecting these injector hold downs. They got little red tab hold downs. Just give it a little pull and it works pretty nice for getting those loose. So you can get this injector unplugged. Now, you know what? I think I'm going to see if I can skip unplugging all the injectors here. Oh man. Note to self, pick by the fan. All right, I'm just gonna plug this guy because that's definitely the one that we're pulling out. So maybe I'll have enough slack in this rail that I don't have to unplug all my fuel injectors. All right, there we go. Beautiful. So I can leave the injectors plugged in. Now, when I pull up the rail, the first thing I look at is my O-rings on all my injectors to make sure that I don't accidentally leave one inside of the manifold or drop it down in there. It just leads to a lot of issues. Like this guy here is hanging out. We're gonna grab that one out of there first. And when dealing with these injector O-rings, you should replace them whenever you change out these injectors. So I have new bottom injector O-rings. Now I'm not disturbing the top, so I'm not replacing the top. But I'm gonna go ahead and get all of my O-rings off before I drop one or lose one or who knows. I just don't want that to happen, so I like to go with this first. Now this would be way easier if I just disconnected all the injectors, and I think I might end up doing that just to get the clearance that I need. All right, so I got 3 in my hand, 2 on the bench, that's 5, and I got 1 still attached to our bad injector, which I'm gonna leave on there. So we got a little hold down clip that we gotta pop off. And hopefully not drop that. There we go. Wiggle, wiggle, and it should come out. There we go. So, again, talking O-rings. This guy right here has an O-ring at the top as well, which did not come out with the injector. Also, when working with fuel, you should have gloves on. So we'll set him off to the side, grab our pick again, and go for that O-ring that's still up in here. There we go. So there's our little blue top O-ring. Our new injector already has 2 O-rings on it. So this guy right here, brand new. And right now our rail is dripping directly into our cylinder. That's not cool. So all the fuel that was puddled up in the rail was leaking into the cylinder. So I've lifted this edge so it leaks onto my rag instead of into the cylinder because, for one, we don't want to hydrolock the motor. All right. So whenever we're dealing with O-rings, a little bit of oil on the O-rings, a little bit of dielectric, something. Put something on there so you don't accidentally roll the O-ring when you're putting it in. So I'm just going to take a little bit of dielectric grease on this O-ring. get this guy installed. Make sure I didn't get a bunch in there. And try to match up the orientation. Make sure I don't have rag stuff on there. All right. And put our clip on. Should click into place on both sides. Should not be able to remove the injector. And I've got new O-rings sitting here. Set those there. I'm going to take a rag now, guys, and I'm going to clean up the bottom of each of these. And then I'm also going to clean up the ports that they're going in, just so we don't try to keep any dirt out of the cylinder as best we can, or out of the intake, lower intake manifold as best we can. Now, if this was direct injected, this would be very, very different, okay? This is still multi-port, relatively low fuel pressure. Direct injected, follow that service procedure, okay? That can really, really, really hurt you. Oh, I think I just lost 2 of my O-rings. All right. In fact, direct injected, anytime you open up a connection in the line, you're supposed to replace it. A lot of them use crush fittings. So something to keep in mind, if you're working with direct injection, do not open the system until it's been depressurized per the service procedure. So now I'm going to throw our new O-rings on each of our injectors, because anytime you take an injector out, you should replace the O-ring. Just sliding them on, again, greasing it up with just a little bit of dielectric, getting it up over its lip there. And this is just going to help make sure that they're sealed. You don't want them leaking vacuum or fuel. In hindsight, I probably should have just disconnected all the injectors and done this on the bench, but now I'm being stubborn and I just want to get it done in the vehicle. All right, 3 more to go, then we bolt that line back down, clean our intake off, put on our new intake gasket, and bolt that guy back down. If this was recorded, I would speed this process up for you guys, because this has to be pretty boring to watch right now. And our last one. Okay, all 6 of our O-rings are in place. Now I'm not going to use the bolts to draw the rail down, okay? We're going to get the rail in place before it's bolted in. So we'll get it lined up and we'll kind of push. Wow, that went actually really easy. Okay, so it's in place. That was way less dramatic than I thought it was going to be. Get our rail bolted back down. Okay. Don't forget the pick. That is a good idea. So I'm just going to go out to service information quick, look up fuel injector, probably find my spec for the rail bolts, because it's a good idea to torque them. 89 inch-pounds. That way there's no question if those bolts are torqued to the proper spec. And yes, they are just a hair over tight at 100 inch-pounds, but I don't think that's going to make a difference here. All right, plug this guy back in. Now we got to go on the hunt for the pick. Oh yeah, that guy is wedged in there. How? Okay. Got our pick. Let's get all our stuff out of the way. So our injector's in. I suppose I could have done a quick ohm test, resistance test on it. Since I just said it, might as well do it. Because just because it's new doesn't mean it's good. Now when I go to fire this thing up here in a minute, guys, because the intake's been off and I did drip fuel down into the cylinder, I'm going to put this thing in clear flood mode for a few seconds before starting it, just to try to clear that cylinder out. There we go. Switch over to the other. There you go. Beautiful. Right where we want to be. That's happy. That's a happy injector. Plug it back in. Now, let's get our intake manifold cleaned up first. So we're going to pull this old gasket out. You want to always replace this gasket because you don't want to end up with vacuum leaks afterwards. So old gasket comes out. Clean up our surface here. All right. So right now I'm just cleaning out the channels or the passage that gasket sits in here to make sure as much of the oil residue and everything that's in there, we get as much of it out as possible. All right, nice and clean. Gasket time. You always want to make sure it's fully secured so it doesn't accidentally get pinched on installation. Set this on the bench and get our lower manifold cleaned off here. Plastic on plastic intake is always nice because you don't really have any sanding, grinding, filing, cleaning, scraping, any of that stuff. Really, it's just a little bit of brake cleaner and the surface is clean and dry. Good to go. All right, back goes down first. We're hooked on our hoses back here. Now if you remember right, I did unbolt this thing and pull it forwards when I did officially remove it. Get them hooked back in. Okay. Now I always like to make sure that we're sitting nice and flat on here, nice and flush, before I start tightening the bolts down, because otherwise you could crack the intake. If something got pinched under this intake when you're tightening those bolts on, even though they're not a very high torque, it's possible to crack a plastic intake manifold. So Everybody gets hand started first to make sure that we have no cross-threading issues. And then look up the spec. Because plastic intake manifolds need to be torqued down in order. I believe this one should probably come in at 89 inch-pounds as well. Stage 1, 89 inch-pounds. Stage 2, 45 degrees. So we'll start off with our little impact set on the lowest setting. So we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So it was 89 inch-pounds on the first pass and then 45 degrees following. One, 2, 3, 4. Is it up first? No, down. 5. 6 and 7. All right, now we have 45 degrees. 1, 2, 3, 4. Oh, down first. 5, 6. And 7. Okay, so still missing the bolt under the throttle body. I will have to go find that later. It's not going to affect the way this thing runs. Intake's bolted down, it's good. So I will find that later, get that bolted back in. Get our fuel rail reconnected. Oops. Is it good? Okay, rail's disconnected. Where's our purge hose? Uh-oh. Is it pinched? Purge hose ended up underneath. But I think we're okay. Oh yeah, nice. So throttle body connector's done, purge is back on, that's back on, get these guys back in place. So I got a hose clamp back there, a hose clamp up here. I'll tighten down later, it's not gonna affect how this thing runs. Get this back on, get this guy on. Airbox is back in place. I think we just got to tighten down the throttle body around there, and I think we're good to go. 7mm on that one. Okay. Anything I forgot? PCV hose on the backside of the intake is Is connected, yes, on the backside. Yes, Downtown Todd, I will remember to get that bolt that goes under the throttle body. I got the pick out of the fan already. It is right here. So we got that guy out of the way. I think what we're gonna do now is fire this thing up in, first we're gonna crank it over in fuel cut, get as much of that fuel out of the cylinder as we can. But before I wanna do that, I wanna reset Keep Alive memory on here because, you know what, let's not reset Keep Alive memory. Let's see if our trimming, once we get back into open loop, if our trimming should go severely negative on bank 2 if this thing is fixed. All right, so I'm in fuel cut, flood mode. All right, so that's kind of just letting the cylinders pump that extra fuel out of the cylinder. And it's also letting the pump kind of prime that air out of the line. There we go. It's alive. Still sounds like it's running bad, but that's because we're running at way, way positive on that fuel trim. Okay, we're already in closed loop. I'm just gonna get rid of some of the stuff that we don't really care about on here for right now. We'll grab fuel status, long terms, and we'll grab short terms. Oh, look at that. That's what I like to see. Our short terms right now are counteracting our very, very high additive fuel on the long terms. Okay, what this will do eventually is this will cause our long terms to come down. Okay, so it's working. It's running the way it's supposed to. Now, we could, because we have a scan tool, we could make this happen faster. And this is the way I would normally do it. I would normally just go ahead and clear Keep Alive memory, which is going to clear out those fuel trims. Functional test, reset Keep Alive. Ford calls it KAM, CAM, Keep Alive memory. That's how our fuel trims are going to be cleared. Beautiful. Go back into data. And unfortunately, it didn't remember our custom graph. Long terms are now zeroed out instead of that positive 28. Oh, try that again. Oh, she's purring like a kitten now. Now it's possible our short terms might go a little bit negative here just because the fuel that we spilled into the cylinder. Plus we had 2 plugs that were most likely kind of fouled out from that entire bank running incredibly rich. So I wouldn't be surprised by a little bit of negative fuel trims on bank 2 before this engine gets nice and warmed up and cleaned out. Now, I didn't do it on camera today to save time, but right after we're done here, guys, I'm throwing a set of plugs in here because it's up near that maintenance mark on this vehicle. Plus, like I said, 2 of them are probably a little bit fouled out on the 2 cylinders that were getting 28% extra fuel dumped into that bank. Misfire PIDs on here should be cleared up. Let's take a look at Misfire Data. That is looking good. Derek, that is a great question. This is where this comes to be a question of the customer, the shop. Honestly, because this job isn't horrible to do, we're not pulling the wiper cowl off, we're not disassembling half of the engine to get to the injectors. In this case, for me, I've only sold 1 injector on this car. because the likelihood of the other injectors failing seems higher now because one already failed. But in all reality, there's nothing coming on Identifix. I haven't heard of injector problems on these vehicles. I'm not putting 6 injectors in here because I want to try to save my customer a little bit of money. You can get the injectors for a pretty decent price. I guess it's going to depend on the customer. Are they keeping this vehicle long term? Is this a good customer of yours that's not going to be upset by a higher than average quote because you've quoted the extra injectors? You got to kind of feel out that situation each time and go after that as you feel best. But personally, in this case, for myself, I have only sold 1 injector on this car. Maybe another one will fail, and we'll have to do a part 2, but I doubt it. I really think we're going to be okay. Yes, Pat. I don't know if I caught a 420 code. It's possible, Pat, that we could run into a CAT code down the road. Now remember, a CAT test most likely never ran because we had a misfire code set. So this is the old clear out the codes, the vehicle's running good again, and then the CAT test finally runs, and we could potentially have a CAT problem. The good thing here is that we had an injector that was high in resistance, pulling less amperage. It probably wasn't opening, and our fuel trims showed us that. Our fuel trims showed very positive, meaning we're running lean on that cylinder, meaning cylinder 4 was most likely just an oxygen pump at that point. So everything kind of found its way out where it needed to be. The fuel trims were able to normalize. Our short-term fuel trim went back to roughly near 0 when we bumped up Bank 2's fuel trim up to 28. So that's telling me that the front air-fuel ratio sensor is running as close as it wants or it can. Because if we were seeing long-term fuel trim really high and short-term fuel trim really high, we would have an issue. But we weren't pegged on long-term. So without even looking at short-term, we knew that we were where we needed to be. If we were pegged, and I think Ford on this one is at 30%, if we were pegged at that mark and short-term showed plus 20 or plus 25, yeah, then we'd have an issue potentially. But I think the computer was able to achieve somewhat of a happy medium, even though we had a bum cylinder on here. It wasn't dumping fuel in, it wasn't running super rich, our fuel trims weren't negative. I have high hopes for the CAT on this vehicle. I really think we'll be okay. It was being fed with extra oxygen, but the fuel trims were able to balance themselves out back to some sort of normalcy on this thing. So yeah, and again, we were in closed loop. If we were in open loop, that would probably be a different story. Yeah, Nick, $300 injectors would be very, very hard to sell 6 of those. So somebody's asking if it's dirty. No, looks pretty normal to me. And remember, it was a winding issue, right? It was an issue with high resistance. Chances are you're not going to see that in a physical appearance in the actual injector. And I'm not seeing anything here. There's no way you guys are going to be able to see it on camera. But I don't see any gunk stuck in here. I don't see any buildup, like, I don't know, somebody was running old crappy fuel. I don't see any of that in this injector at all. I don't know, maybe it was a Friday afternoon injector. Who knows? There's some reason this thing failed. Maybe it's just a fluke on here. Who knows? Alrighty. Oh, that's right. We still got to do a t-shirt question. Any other questions on anything that we covered today regarding misfires? Fuel, air, spark, and compression, the 4 necessary components to make our engine run. Check each one. Do as high level of a test as you can, because really, the quicker we can diagnose this thing, the quicker we get it fixed, the more money we make in the end, right? Most of us, not most of us, a lot of techs out there are still driven off a flat rate. So, t-shirt question. To win one of your very own, to earn one of your very own diagnose before you triagnose t-shirts that are coveted out there. Let's take a look at what we got. All right, in regards to a single cylinder misfire trouble code like we're dealing with today, a relative compression test was performed, and now we're not using software that seems sketchy. This is a true amp clamp scope relative compression test. This is a true relative compression test. One cylinder is showing a higher peak than the other cylinders, but that cylinder has been determined to not be the same one that's setting the code. So maybe their ignition sync was working properly. They determined that that cylinder was not the one setting the code. The high peak was not setting the code. The text A says that the PCM's probably wrong. It's got to be wrong, right? And he goes after inspecting that cylinder that's reading the higher peak. Okay? Tech B says that higher peak on that cylinder could potentially be showing an issue with its mate cylinder. Who's correct? Who's wasting their time? Who is going down the right path here? Which tech do you think is providing the most accurate direction for this diagnosis? Who's barking up the right tree here? Is Tech A thinking the PCM is wrong, or is Tech B with his reasoning of mate cylinders? So I want to know what you guys think, A, B, C, or D, or Tech A, Tech B, both, or neither. But then I also want to know why. Give me an explanation of why that could happen, or why that situation could occur. Again, the giveaway is only valid today, September 5th of 2019, to the first 5 correct answers that send it into my email address, which is right here, mcbecker@ngksparkplugs.com. Only valid today. If you send me an email tonight at 12:01, you will not be counted. Sorry to those of you that are 13 hours off from us right now. Maybe I would count you in if you include where you're from and why you're sending it in 13 hours late. But that's a story for another day. Any other questions, comments, or concerns regarding this class? And your answers in this chat do not count. These do not count. So Downtown Todd, Joe Bush, Mackenzie M, Clive, all you guys, send me that email. Send me that email. Alrighty. I think we're going to close it out then, guys, unless anybody else had any questions. If you're looking for more training, be sure to check out the rest of the videos on the channel, or head out to ngktechportal.com. Okay, this is our new training website. You'll be able to log in. You got to take some pre-tests and some post-tests. And once again, this training right now is tailored towards the beginner, somebody who's just starting out in the industry, somebody who's trying to learn more of the system-focused basics type of thing that we're graduating into the harder stuff. It'll get there. We're going to build this up as we go, okay? We're going to start with the easy and steer them in the direction of the more difficult, lab scope, hands-on, that type of stuff. So check this out if you're looking for some more training. As always, guys, please go out, thumbs up the video, subscribe to the channel if you haven't. That really means a ton to us. And I guess, yeah, we'll see you next time. Really, really appreciate it. Here. Let me just copy and paste this link for you guys. Boom, there you go. That's where you're headed. So go check that out again. I really appreciate everybody being here, spending an hour and a half with me checking out a misfire on a fuel injector problem. Spanky, I hope you were still around. I know you said you had to leave and you were wondering if this would apply to other vehicles. All of the testing that we did today, besides like specific hookup points in the fuse box or whatever, all of the testing that was performed today can really be performed on any vehicle when you're looking for a misfire. All right? So thank you again, guys, for watching. Thumbs up, subscribe if you haven't. Leave a comment below if you have any questions. Feel free to reach out. Yeah, that's it. So thanks again. Happy wrenching, everyone.